Good morning everyone. I self Farhana Sultana. I am going to deal up on single topic UV visible spectroscopy. Introduction. Ultraviolet and visible absorption spectroscopy is the measurement of attenuation of beam of light after it passes through a sample or after reflection from a sample surface. Absorption measurement can be at a single wavelength or over an extended spectral range. This absorption is characteristic and depends on the nature of electron present. Types of transition. Four types of electron transition are possible. First is sigma to sigma star transition. Second is n to sigma star transition. Third is n to pi star and pi to pi star transition. First, sigma to sigma star transition. An electron in a bonding sigma orbital, a molecule is excited to the corresponding antibonding orbital by the absorption of radiation. To induce in a sigma to sigma star transition, it requires large energy. Second is n to sigma star transition. In this type, a saturated compound containing atoms with unshared electron pair are undergo n to sigma star transition. It requires less energy than sigma to sigma star transition. Third is n to pi star and pi to pi star transition. Most organic compounds undergo transition for n to pi star and pi to pi star transition because energy required for the process bearing the absorption peak into the spectral region. Absorption law, Lambert's Beer law. This law states that when a beam of monochromatic light is passed through a solution of an absorbing substance, the rate of decreases of the intensity of radiation with thickness of the absorbing solution is proportional to the intensity of incident radiation as well as the concentration of the solution. Mathematically, this law may be expressed as below. Epsilon is known as molar extension coefficient. I by I0 is called transmitted. Log I by I0 is called optical density or absorbance. Plot of absorptions or OD versus concentration. We will get a straight line with positive slope. Some important term is used in UV visible spectroscopy. Chromophore. Chrom means color, phore means to impact. Chromophore is a functional group present in a molecule for the evaluate absorption of the molecule. Oxychrome is a functional group of atoms with one or more lone pair of electrons. When attached to a chromophore, alters both wavelength or intensity of absorption. Example: if a compound contains carboxylic group C-double-O moiety is known as chromophore and OH moiety is known as oxychrome. Effect of solvent polarity on pi to pi star and n to pi star transition. In case of pi to pi star transition, a pi state is comparatively more stabilized than the pi state and hence energy gap is decreased. Hence an absorption band moves to higher wavelength. This is case of bathychromic shift. Bathychromic shift is also known as red shift. In case of n to pi state transition, a polar solvent stabilizes in a pi state more than pi state. As a result, which is energy difference is increases and absorption band move to shorter wavelength. This is case of hypochromic shift. Hypochromic shift is also known as blue shift. Choice of solvent. It should be transferred in the wavelength region under the examination. That is, it should not itself absorb radiation in the region being examined. It should be less porous so that it has a minimum interaction with the solid molecules and has no effect on the fine structure of absorption band and position of the absorption band, the most commonly employed solvent. Lycopene. Tomato is a red color because it is a present lycopene. Lycopene gives red color because lycopene has a 11 conjugated double bond. Conjugated energy is decreases, the wavelength is increases and hence color is shown. Application. Quantitative and qualitative detection of impurity, detection of isomer are possible, detection of unknown compound. Advantage. Simple and inexpensive instrument. Most organic molecules absorb quantitative. Disadvantage. In a liquid sample are possible to analyze, take time to get ready to use it. The result of the absorption can be affected by pH impurity. Woodward-Fisher rule for conjugated diene and polys. Introduction. In 1945, Robert Burns Woodward gave certain rules for correlating maps with molecular structure. In Luce 1959, Frederick Fisher modified this rule with more experimental data, and the modified rule is known as Woodward-Fisher rule. It is used to calculate the position and for a given structure by relating the position and degree of substitution chromophore here. This type of dyne and tine system is having a certain fixed value at which absorption takes place. The contribution made by various alkyl substitution of ring residue, double bond extended conjugation and polar groups such as Cl, Br, etc. are added to the basic value to obtain compound. This is the value in homoangular and heteroangular. Example. This is the example. This is my reference. This is my acknowledgement. Thank you.